right, we're going to do our video about some specifics that we have to do with two independent means and matched pairs. What we want to do is talk about how are these phantoms and panic, what's all the different notation, how is there different wording, lots of little intricacies in writing up the difference between two independent means and matched pairs. So I have a side-by-side comparison to help you with that. So we'll take a look at this data and this information. I want to begin by talking to you about the examples that we're going to follow, two separate scenarios throughout this entire process, okay? All right, so the first problem that we're going to talk about is one that's the two separate means, and we're going to do a test first. So this is a situation where we had men and women and their college GPAs, okay? And there was the supposition that the women in the class say that they believe college women tend to have higher GPAs than college men do, okay? So this is a problem. Two separate sets of subjects, two independent means. In fact, there's not even the same amount of subjects in each one of these sets of data. Okay? The information that we were provided with, we were given dot plot or histograms of each one of them. I do not have them listed here, but it was showing that each one of the histograms were somewhat symmetric unimodal and no outliers, and that was good because we had small sample sizes. But we can see the way that data was provided to us, it was in summary statistics form, so we would end up using that whenever we did our calculators information. All right, let's take a look at what we got here for the matched pairs situation. This one I talked about in the previous video. This was about the 16 randomly chosen students from this professor's students and their before and after taking the class anxiety level. Did taking the class reduce their anxiety? On average, what did it do? Okay, so it said, does the data indicate that average anxiety level amongst these professor students change after they take the course? All right, so let's first look at the parameters. Okay, so here we go. So the parameters that we have, let's take a look at the two means. Do you see how we have two separate means symbolized here? Two separate notations. The average GPA of all such college men and the average GPA of all such college women. Okay? But on the other side, where we had paired data, we don't care about the average of the pre and the average of the post. I do not care where their anxiety levels began or ended. I just am interested in where the difference, the average of this list of differences. So one mean of that differences. Mu, and then I did A minus B, so the after minus before. So when you define this parameter, a couple of things. The average change or the average difference in that anxiety level. Put what the parameters were, or what the treatment, or what happened, what was occurring to perhaps cause this effect. Okay? Which was after students take the AP course. That was the thing we were supposing was making the effect. Okay, so you want to include that, and you also want to include the way in which you subtract. All right, so let's take a look at how these hypothesis statements look different. So over here on the left, when we have the two separate means, you can see I have two means written separately. I have the average of the men equaling the average of the women. Okay? And the alternative, pay attention to what they were wondering about. They gave us the data in the men's first and then the women's second, but then they asked the question, in in the viewpoint of the women think they have a higher GPA than the men. So paying attention to how you're putting that data in, because the calculator will do the first minus the second. Of course, alternatively, you could have written this as the average of the men minus the average of the women equals 0 for the null, and you could have done the average of the men minus the average of the women is less than 0 for the alternative. Okay, I usually like it the way I have it written there. Now, take a look at how this hypothesis statement looks when the data is matched. Okay, here we just have one mean listed here. The mean of the after minus before is equal 0. And on this one, the mean of the after minus 4 is less than 0 because we think it's gone down. We think the average anxiety level decreased. We're not making statements about individuals, just about the average. All right, so let's see how our assumptions look for each one of these. We're going to get real. So on the left, where we had 2 means, we said that in both cases, we talk about both means. So we had randomly selected 13 men and 19 women was stated. All right. Independent, N is less than 10% of the population for both groups. So 13 is less than 10% of all such college men. 19 is less than 10% of all such college women. And look right here. Our last independent one is that the men, the men's GPAs are independent of the women's GPAs. Nobody was double counted in those groups. Okay? And so let's take that over here. Let's take a look at just those 2, random independent on the matched pairs. So because we just are talking about this one set of subjects, we're just talking about that we had 16 randomly selected students from this professor's students. And because we know that professor had 180 students, that we know that this 16 is less than 10% of all this professor's students, okay? And then here, notice this is different than the other side, okay? We're not saying the post-anxiety and the pre-anxiety measures are different, independent of each other. No, because those are related. We are saying each student's anxiety level is independent of the other student's anxiety level. So each of the 16 subjects' results are independent of the other subject's results, okay? All right, and here we go. We don't have large enough samples in either one of these cases. But over here on this side, the 13 and the 19 are not large enough. However, both cases, the histogram was provided, and both of them show that they were somewhat symmetric unimodal and no outliers, so the approximately normal model applies. We were not given the histogram or dot plot on these 16 pieces of data, so we had to come up with that on our own. So a couple of things about the labels that I want to point out. Make sure that your label down here does not just say anxiety level. No, because if you just say anxiety level, what are you doing? Are you doing the pre? Are you doing the post? What are you doing? No, I'm not doing the pre or the post anxiety levels. I am putting down 16 pieces of data, and the pieces I'm putting down are those ones that came from the differences in anxiety. The -3, the -2, the -1s, and so on, okay? And put the way that you subtract, okay? And then we got our number of students on the left. That was some sun, so approximately normal model applies. All right, so there's our parameters, hypotheses, and assumptions. Next, here is showing you the name and then how it actually looks different in the calculator, okay? So over here on the left-hand side, we've got the 2 mean t-test, and on the right, 1 mean t-test for matched pairs. Make sure you indicate for matched pairs. On the left, we had our 2 sample t-test, and the statistics is what was given to us. We had the summary information, keeping straight men information in and women information in, so we can see that we were putting that the men was less than the woman. No pooling. Okay. On the right-hand side with our matched, we actually had been given the actual pieces of data, not summary statistics, okay? So we had put in our list 1 and our list 2. We did the subtracting to get the list 3. I'm not interested in L1 and L2, just L3. So I'm going to do my 1 mean t-test. So notice it was just this regular old t-test in the calculator on list 3. But notice this, the null hypothesis, I leave it equal to 0. And I'm leaving it equal to 0 because that's what our null hypothesis said was 0 change on average. Okay? All right. And then we supposed it decreased and we got our information. So that was, I just put that in there so you could see how those calculator computings look differently. And here comes our test statistics. So those are the ones that actually just came out whenever we plotted that information. Wanted to draw your attention to this situation here. So make sure you're listing your t-score, your p-value, and don't forget the DF, T, not Z. And for 2 means, that gives it to you in the calculator printout because it's like a really funky formula. But for 1 mean, it doesn't. This is 15 because it came from 16 minus 1. But again, I wanted to show you this right here. This p-value came out like that. It actually, the way it looked in the calculator was something like 6.78 number. I don't know what all the numbers are that it had. And then it had a little e, -4. So it kind of looked like that. Well, when people glance at that, a lot of times they'll just see, oh, that's 6.8, and they just put 6.8, and then they just go on from there, and so on and so forth. But 6.8 should kind of make you freak out a little bit. 6.8 means 680% chance of getting that sample or something more extreme if there is no difference. So that's no, you can't have 680% chance of something. So that, look at the end of the line, and that was times 10 to the -4th. So we obtained a p-value, we compared it to alpha. In both cases, they were less than that, so we rejected the null. So therefore, in both cases, we do have evidence of HA, but let's take a look at how that looks. So on the left, when I'm writing my conclusion, I'm writing it with 2 averages words. See, I have evidence suggests that the average GPA of all such college men is less than the average GPA of all such college women. Of course, I could say it how they asked the question specifically. You know, that's always safe, is to use the exact same way that they use the language of the question, which was that the average GPA of the women is greater than the average GPA of the men. Means the same thing. But let's look at how this is written out different and discussed differently. There is evidence to suggest that the average change in anxiety level after the students take the course decreases. The average change decreases. Not every single person did it decrease. A couple of people, it stayed the same, and one person, it even increased. Okay? So when you make conclusions, it's about averages, not individuals. All right. Now, let's take a look at how this would go in a interval. Okay, how would this go if we were doing our interval for matched pairs versus 2? So the same problems. Parameters and assumptions are the same as what we showed on the previous test. So that's the P and the A. So now we're to the N of our panic model, 2 mean T interval. one mean t interval for matched pairs. Okay? So I did not show the calculator printout here, but you just, once you did that in the calculator, it came out like this. Look at how I write this here. Subtraction with the two means. Don't forget the DF. Look at how I wrote this here. Subtraction for one mean. See? The mean of those differences. Okay. Don't forget the DF. All right. In both cases, they actually were both negative. So that's interesting. So let's talk about what that's saying. That in this case, in both cases, the men was lower than the women on the averages. So I am 90% confident that the average GPA of all such college men is between this and this points lower. The men was lower than the average GPA of all such college women. And remember, when we're talking about those differences, we need to have that zero connection. So since zero isn't in there, the entire thing is contained below zero. So this is evidence of a difference, that there really is a difference in between the average GPAs of men and women. Over here on the right, we also had that, but I'm 95% confident that the average anxiety level after students take the AP class decreases between this much and this much points. Okay, always very much contextually driven. And in this case, again, zero was not in there, so this suggests that there, on average, the anxiety level changes. In the case, this case decreases. All right, so I wanted to be thorough. Oh, and I have a piece missing. Let me see if pooh. Yeah, I have a piece missing about, darn, it says what happens if those things did not include, or they did include the zero. Okay, so let me just pause here for a minute, and I'm going to pull that in because it's important that I get that complete conclusion in there for you. So let me see if I can't go find that and put that in there. I want to talk about what happens if that occurs. So let's see if I pause this. All right, so I'm sorry you might not have this page in your packet, but I do want to have this discussion with you. Suppose that, what would we do if our p-value was greater than alpha? Okay, our p-value wasn't low and we did not reject HO. Okay, so let's say we had this situation in that first section. So if the p-value is greater than alpha, then I would fail to reject the null hypothesis. Okay, so then I do not have evidence that the average GPA of all such college men is less than that average of all the college women. Okay, I would not have evidence. Let's actually just kind of look at what that interval would look like in that case. If that was the case, if we failed to reject, we don't have evidence of a significant difference. So see, zero would have been in there. Okay, and since zero is in that interval, then there is no evidence of a significant difference between their average GPAs. Okay, in this case, with this problem, we have a situation where the men have lower than the women, up to the men having higher than the women. So here's how I wrote that. I'm 90% confident that the average GPA of all such college men is between 0.82 points lower than the average GPA of the women, up to, could be as much as 0.045 points higher than the average GPA of all such college women. Okay? And so again, no evidence of a difference because zero's in there. All right, what happens with our matched problem if our p-value was not low? If our p-value was greater than alpha, then we would fail to reject the null, so we would not have evidence that the average anxiety level decreases after they take the course. Basically don't have enough, it's not a significant difference on average, okay? So the interval might look something like this. So we have this situation where we're going from negative 1.63 to positive 0.62. See, and we had no evidence that the average had decreased. So the zero statement, so the zero is in that interval. It makes sense that that zero is in there because, again, we have no evidence that that average anxiety level has decreased or gone down. So specifically, the way these numbers would be addressed is saying that, after the course, it could go down up or up, it could go down this much on average, or it could go up this much on average. So I'm 95% confident that the average anxiety level after students take the class could go 1.63 points lower anxiety up to 0.62 points higher anxiety. Okay? And since zero, it could be lower, it could be higher. I don't have evidence of a significant difference. Okay, so I hope that those conclusions helped you to better understand all the details between two independent means and matched pair means.